Good morning, chemistry students. This is the only teaching video I'm going to make for experiment 9, the empirical formula determination. So based on this, you'll have what you need to be able to do your lab report. So just going over the lab like we typically do, going over the lab procedure, so follow along on the lab paper that you have in Google Classroom. So this is experiment 9, empirical formula determination. Purpose: to determine the empirical formula of magnesium oxide. Background: carbon dioxide, water, and ammonia are just a few of many chemical compounds that you are familiar with. Have you ever seen a compound with a formula such as Na.23 Cl 3.9? In fact, such a formula is impossible. Only whole atoms, not fractions of atoms, react with each other to form products. Also, although elements may react with each other to form... Although elements may react in different proportions to form more than one compound, the proportions of atoms in those compounds will always be in a ratio of small whole numbers. So again, you guys remember that's because, remember, our basic building block is an atom, and although there are smaller pieces inside of atoms, they don't really exist by themselves. So whole atoms have to combine with other whole atoms. An empirical formula gives the simplest whole number ratio of the different atoms in a compound. For example, while the molecular formula for hydrogen peroxide is H2O2, the simplest whole number ratio of hydrogen and oxygen atoms can be expressed as HO. Thus, the empirical formula for hydrogen peroxide is HO. So remember, molecular formula, it's not reduced, it's not its lowest whole number ratio. Empirical formula is always the lowest whole number ratio of the atoms in the element, or in the compound. In this lab, you will experimentally determine the empirical formula of magnesium oxide, the compound formed when magnesium metal reacts with oxygen. Materials: you would have safety goggles normally, a crucible lid, crucible tongs, clay triangle, ring stand, ring support, centigram balance, gas burner, exposed film, and magnesium ribbon. Safety first. In this lab, the crucible you are working with will become quite hot and could cause a severe burn if handled improperly. Observe all precautions, especially the ones listed below. If you see a safety icon beside a step in the procedure, refer to the list below for its meaning. Caution: wear your safety goggles, all steps. Caution: do not look directly at burning magnesium. Do not inhale the smoke produced when the magnesium is burned. For those of you who have asthma, if we were doing this in class, I would tell you to make sure you had your inhalers with you when you came to do this lab. Caution: always handle the crucible and crucible lid with crucible tongs as shown in figure 9.1, and return or dispose of all materials according to the instructions of your teacher. So, procedure. As you perform the experiment, record your data in data table 1. Okay, we'll look at that eventually. Step number 1. Set up the experiment as shown in figure 9.2. Clean a crucible and its cover with water. Dry them by heating in the hottest part of the flame for 5 minutes. Allow them to cool for at least 10 minutes. Measure and record the combined mass of the crucible and lid to the nearest 100th gram. Step number 2. Place a coiled 25 centimeter length of magnesium ribbon in the crucible. Measure and record the combined mass of the crucible, lid, and magnesium. So typically when we coil that, we coil it really, really tightly, and so it kind of ends up looking like this. So a little piece of magnesium ribbon that looks like that. Magnesium ribbon is kind of a dull silver color. Step number 3. Caution: do not look directly at the burning magnesium. View the reaction through the pieces of film provided by your teacher. That is because this is the same type of element that's used in welding, so you definitely don't want to look at the burning magnesium. Over a high flame, heat the uncovered crucible on the triangle until the magnesium ignites. Caution: do not inhale the smoke produced. When the magnesium begins to burn, immediately cover the crucible using tongs and remove the burner. So again, you have your Bunsen burner and you have your crucible sitting on your clay triangle, okay? And that magnesium is kind of all wound up and in the bottom of this crucible. And so you're heating this over the high part of the flame until this magnesium on the inside catches fire. This is definitely sometimes a source of error. Sometimes students have a really easy time getting that magnesium to catch on fire, and other times some students and some groups have a really hard time getting their magnesium to catch on fire. Number 4. After smoke production has ceased, replace the burner and continue heating the crucible. Caution, do not lean over the crucible. Remove the burner and carefully lift the lid and check the reaction every 2 or 3 minutes. After heating for a total of 10 minutes, check to see if the reaction is complete. The magnesium should be wholly converted to a light gray powder, magnesium oxide. If ribbon-like material remains in the crucible, replace the burner and continue heating. So this is definitely an area where there are sometimes sources of error. First off, your crucible has like a lid on it. So why is it, do you think, that as you're heating this, you have to take the lid off of it every 2 to 3 minutes? Remember, we have solid magnesium as our reactant, and we're going to produce some sort of magnesium oxide. So what is the other reactant that we need to form magnesium oxide? We need oxygen. Where is that oxygen going to come from? The air. So part of the reason why you take this lid off of your crucible every couple minutes is so that you can replenish the air inside of that crucible. Remember, one of the ways to put out a fire is to smother it, and when you smother a fire, you are depriving it of the oxygen that it needs to burn. So we don't want to smother our burning magnesium inside that crucible. So part of the reason that we are lifting the lid and checking it is because we need to replenish the oxygen inside that crucible. That's sometimes a source of error. Sometimes people are not very conscientious about how often they lift that lid and check it. The other part of this is about the wholly converted to a light gray powder. So you would have been instructed by me to take that magnesium strip and wind it really tightly into this tight little ball. So sometimes what happens is, I want you to kind of think about when you have seen a fire before, like a bonfire, and there's a piece of wood in there. That wood sometimes is burnt. And even after it's burnt, it still looks like a piece of wood. It still has that same shape, correct? You've hopefully have seen that happen. Well, that same thing happens with this magnesium. Because we have it wound so tightly, even though it's burnt, it sometimes still kind of looks like it might be in its ribbon-like form. So again, another kind of source of error is sometimes having a difficult time telling whether that magnesium has actually finished burning and become this light gray powder. Sorry. Step number 5, turn off and remove the burner. Allow the crucible to cool completely at least 10 minutes. 6, measure and record the combined mass of the crucible lid, and magnesium oxide. 7, follow your teacher's instructions for proper disposal of the materials. So again, we're not going to actually do that lab. I'm not even going to make a video doing the lab because there's really not much to see with this lab. So you're just going to use the procedure there to kind of go over to write up your lab report. So I do want to go over the rubric and lab report a little bit, just to remind you, it's been a while since you've done one. This is your first one this trimester. So one of the things here is, remember, to write your lab report, you should have your rubric right in front of you. And remember, you have your cover page, and I think everybody was doing pretty well with that. With the body of the report, you have your purpose. Remember, don't use the purpose that's on this lab directions, because it's, number 1, it's not a complete sentence, and number 2, it's plagiarism, but come up with a purpose. Theory, remember in the theory, again, I'm asking for the definition of an empirical formula in your own words, the molecular formula. You have to show the equation for percent error, okay, and you have to write what the correct empirical formula for magnesium oxide is, and then you're going to answer that analysis and conclusions question number 11. And again, remember, you're just going to answer that in complete sentences and in a paragraph form. Experimental, remember these are the steps that you follow to do the procedure. So again, you're going to summarize the procedure. Probably not going to write out all of those steps. Again, you're probably going to summarize the steps. The results. So notice you have to have two different data tables, although you can combine it all into one, but you have to have the information. This is the stuff that's in the lab, but this is one that you're going to create. And there's nothing fancy to it. All it is saying here, and we'll talk about this as we go through the calculations, I want your data table A that has the 3 lines in it, okay? But then I want you to add to it. For example, number 1, you determine the mass of magnesium used. So I want mass of magnesium used, and then I want your number that you calculate. And so you're going to take just the answers from the calculations you do for this lab, and you're going to put just those answers in a data table. Okay? So that's what I mean by this, okay? By the results of all your calculations in a data table. Just the numbers you get at the very end of your calculation, okay? And then analysis and conclusions. Again, I'm referring to the questions. So question 7, question 9, question 10. And then a comparison. With this comparison, I really want you to use your percent error that you calculate, right? If you have a low percent error, it means that you did a pretty good job doing the lab. If you have a large percent error, it means that perhaps you made more mistakes during the lab. So I really kind of want you to make a comparison, and that comparison to be using your percent error. Now, this is new. You haven't had to do an appendix yet. So this is the first time you do an appendix. An appendix is going to be a totally separate page on the end of your lab. Okay, I'm going to tell you right now, I don't want you to type this. You're going to waste a lot of time typing it up. I'd rather you spend that time doing something fun and not chemistry related, okay? So this is going to be handwritten. I would like you, though, to do it in ink. And most of you are pretty tech savvy. So I'm guessing that most of you are going to be able to figure out how to take a picture of your appendix and actually add it as a last page of your lab report. Okay, so that's kind of what I expect you to do. Is after you've typed it, you're going to add kind of an extra page on the end of your lab report that you're going to call the appendix, that it's going to have a page number and your last name like lab reports always do, and then you'll have the picture of these calculations. Now, what do I want here? I want for each calculation, okay, so for each calculation, choose a different color that shows up here, okay, for each calculation, I want an equation, plugging in your numbers and units, and then your answer with the correct units and significant figures. Okay? So let me kind of give you an example, and we're going to talk about this, how to actually do these calculations in a couple minutes. But let's say we're looking at number 2. Okay, so analysis and conclusions number 2. So I don't care if you say that it's number 2, that's fine. But then you're going to have some number, let's say it's 0.08 grams of magnesium. It's going to be your answer from number 1. And you're supposed to convert it to moles of magnesium. So you're going to use grams of magnesium to 1 mole of magnesium. And again, this number in front of grams, this comes from your periodic table because that's the molar mass of magnesium, equals, and then you're going to have your number, You're going to have moles of magnesium. You might even say used, so you keep track of it. And then this number that you report has to have the correct number of sig figs. So that's what your work would look like for number 2, okay, on your appendix. So I really want you to show me all of your work, okay? So your appendix is a separate page. It's not going to be typed. It's going to be handwritten in ink, and basically it's going to be all your calculations. There's still spelling, right? Every time I find a spelling mistake, you'll lose a point. Grammar, when I can find a grammar mistake, you'll lose a point. Absence of contractions, that means that if you use type can't instead of cannot, you're going to lose a point. And then again, that you have your last name and page numbers in your headers, including on your appendix. Okay, 125 points. Do not delete the grading rubric off of when you turn in your lab report, because remember, I type in it to give you points so you know where you earned points and where you didn't. So typically the calculations are what give people a hard time with this lab. So this is the data table that you would do if you were in lab, and again, I'm going to provide you with data to use for this lab. But we're going to say that our empty crucible and lid, that's our A. So whatever number you have here, we're going to say it's A. So I'm not going to use numbers as I talk through how to do these problems. I'm going to kind of refer to this A, B, and C. So when I say A, I'm talking about the mass of the empty crucible and lid. When I say B, I'm talking about the mass of the crucible lid and magnesium before you heat it. And when I say C, I'm talking about the mass of the crucible lid and combustion product. Okay? So step number 1 says determine the mass of magnesium used. So how with this data would you figure out how much magnesium you used? Well, that would be B minus A gives me my answer to number 1 in grams of magnesium used. So that's how you're going to determine the mass of magnesium used. You're going to take B and subtract A. Number 2, determine the number of moles of magnesium used. So you're going to use your answer from number 1 of grams of magnesium. Grams of magnesium have to go on the bottom. Moles of magnesium go on the top. This is your molar mass. So remember our molar mass, this number is going to come from our periodic table, the mass for magnesium. And when you do that calculation, you're going to get your answer to number 2, which is in units of moles of magnesium, right? Because your grams of magnesium have crossed out. Number 3, determine the mass of magnesium oxide formed. So again, you're kind of going back to your data table and figuring out how can I figure out how much magnesium oxide I produced. So to do that, you're going to do C minus A, which gives me my answer to number 3, my grams of compound formed. Number 4, determine the mass of oxygen that combined with the magnesium. Well, my compound has both magnesium and oxygen in it, and I know how much magnesium there was, so to figure this out, I'm going to take my answer to number 3, which was my grams of compound, and I'm going to subtract my answer to number 1, which was my grams of magnesium used. Right, so this compound has magnesium and oxygen in it. This is just the magnesium, so that's going to leave me with my answer to number 4, which is my grams of oxygen that combined. Number 5, calculate the number of moles of oxygen atoms that were used. So again, I'm going to take my answer to number 4, okay, my grams of oxygen, Again, I'm going to use the molar mass of oxygen. But notice it's oxygen atoms, so I do have to be careful. Notice this is oxygen, O, not O2. Okay? So I'm going to use my grams of oxygen. Again, this comes from my periodic table, my mass of oxygen. And this is going to give me my answer to number 5 in moles of oxygen used. 6. Calculate the ratio between the moles of magnesium used and the moles of oxygen used. Express this ratio in the simplest whole number form. So what this is asking me to basically do is take my answer from number 2, my moles of magnesium used, to my answer as a ratio to my answer to number 5, my moles of oxygen used. Now, that sometimes is hard to do because sometimes those aren't nice whole numbers. So, my suggestion for this, okay, is that oftentimes this won't give you a whole number. Okay, so I suggest you kind of approach this like you do empirical formula determinations, where when you have like 1.53 moles and you have 0.50 moles, you divide both of them by the smallest. So you get 1 mole here and you get half. I can't do that math in my head. I should have chosen something simpler. Let's make it simpler. Let's say it was, let me come up with a number. All right, let's make these a little bit better numbers to use for this. So let's say when we did this, we got 1.66 moles of magnesium, let's say, and we had 0.33 moles of oxygen. Okay? So I take both of these and I divide them by the smaller number. So I get 1 mole of oxygen, and 1.66 divided by 0.33 is 5.03 moles of magnesium. So then I would say that my empirical formula was Mg5O. Okay, so sometimes what I'm saying here is that you may have to fudge this. Okay, if this dividing that I have in green doesn't work and give you a whole number, and you can fudge it by divide both numbers by the smallest, like you do when you do empirical formula determinations. Okay. Now, after you do that, you should get, right? What we're talking about in number 7 here is number 7 wants this. Because number 7 says, based on your experimental data, write the empirical formula for magnesium oxide. So that's saying after you do this, however you do it, what's that empirical formula you got? So in my example, it was Mg5O, but you're going to just have Mgx some number and Ox some number. And the x's come from the ratios in number 6. Okay, in your answers from number 6. So this is just asking you to take that information and make it a chemical formula. Number 8, calculate the percent error in your determination of the magnesium to oxygen mole ratio using the accepted value provided by your teacher. Your teacher's mean. I'm not providing that. I'm telling you this. You can figure this out by doing, or by, let's instead of saying doing, by writing the formula for the compound magnesium oxide. Like you did back in chapter 6 when you wrote chemical formulas. So you can write the chemical formula for magnesium oxide, which gives you the accepted value. Now, let's say you got Mg 3O4 as your accepted value. How do you use this percent error equation? Okay, so this is an example. This is not what yours is going to be. I'm just using the numbers, right? So my experimental value was an Mg50. I said the accepted value was Mg3O4. Okay, so how would I do this? Well, what I'm going to do is use these numbers as kind of ratios. So my accepted value is 3/4 minus my experimental value, which is 5/1, divided by my accepted, which was 3/4. And then I'm going to convert those to decimals, right? So basically this is saying 0.75 minus 5 divided by the absolute value of that, divided by 0.75 times 100. So you would do something like that with the numbers that you got. Again, my 3/4 came from my accepted value and my experimental value. Question 9, identify major sources of error in this experiment. Explain how the magnesium-oxygen ratio would be affected by each error you identify. Besides the ones I mentioned, remember that you're using a triple beam balance. Some people don't read triple beam balances very well. Okay, read through the procedure a little bit and see if you can come up with some other spots where mistakes could be made. Okay. Number 10, is there agreement among the results obtained by others in the class? What does the class data tell you about the empirical formula of a compound? Well, you're going to have agreement, right? Because everybody's using the same data. But in a real circumstance, there often is some disagreement. So use that information and kind of come up with a way to answer this, okay? So again, what that kind of suggests is this isn't the easiest lab to do. Number 11, interpret in terms of atoms and in terms of moles the subscripts in a chemical formula such as C2H6. People often make this harder than it needs to be. In terms of atoms, right? This is 2 carbon atoms and 6 hydrogen atoms. In terms of moles, it works the same way. In terms of moles, there are 2 moles of carbon atoms and 6 moles of hydrogen atoms. So it doesn't require any math to answer this question, okay? It's just interpreting it this way. So that brings you to the end of the pre-lab. I know it's not ideal to do a lab report when you haven't done the lab, but a big part of the purpose of the lab report is to help you improve your writing in science. So that part of it you can still do. I've provided data in Google Classroom for you to use to do all of your calculations. So have a great day. I'll talk to you tomorrow.